sure we record. So, keeping in mind finding our unknown length. So you should have your picture labeled with A, F, E, and D. In the video today, they don't really call it A, F, E, and D, but you're going to see them solve this problem. I need you to put that we are going to find the distance from A to E first. So when they show you finding the first hypotenuse, you are finding the distance from A to E. I'm going to put that distance up here as a dotted line in blue. I'd like you to do similarly in your picture. Put a dotted line from A to E. Okay. Do you see a right triangle from AFE?
Yeah.
At the bottom, right? So this is a right angle. Because if you're thinking about like a cube, this is like a box, right? So this is just that right angle on the bottom. Okay. And so first you're going to find AE, and then the second step, you're going to find another hypotenuse. So both of these are going to be hypotenuses. Hypotenuse is always the what side? Longest. That's our side C, that's our hypotenuse, the longest side. And here, the second step will be to find AD. And AD in this picture is already drawn for you as a orange line. But I want you to notice that if I was looking at a right angle, this is my right angle right here, okay? This is the right angle, okay? You're going to see it in this video, but I want you to have these down because you're going to use the Pythagorean theorem twice as we do these box problems to find this. You'll see it in the video as we are doing it, okay? So, if you have that kind of labeled, and it's super easy when you're thinking about these to just put it in your calculator and do these. But you need to have at least some information. The other thing is in this video, what you're going to see is that they are going to always approximate. When I talk about approximating, they're going to give me, where do I have that? They are going to give me this length as a decimal. I don't want you to do that. We're going to keep it exact. Because when you are in any field where you are actually using this, we don't ever want to approximate till the very last step. So, as you take a look at this video.
How do you find the length of the red line segment inside the cube? In this lesson, you will learn how to apply the Pythagorean theorem to three-dimensional figures by creating right triangles. Let's review. The Pythagorean theorem. So one formula you can use for the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are legs and c is the hypotenuse. Another formula is leg squared plus leg squared equals hypotenuse squared. Another topic to review is the sides of a rectangular prism. So here we have the length, which is highlighted in blue, the width, which is highlighted in red, and the height, which is highlighted in green. And there are congruent sides of the rectangular prism. So here we have other equal lengths, equal widths, and heights. And here we have a cube, and one side of the cube can be called the edge. And so all the edges of the cube are equal. A common mistake to make in these types of problems is not recognizing the two right triangles needed to solve the problem. So say we're looking for the value of x in this problem.
So they drew theirs a little differently.
What sides of the triangle do we know? We only know the height of the prism is 6 feet. We still need to know what y is before we solve for x. So one way to solve for y is to use the width and length of the rectangular prism. So in this case it would be 7 feet and 3 feet. Do not assume any side lengths when solving a problem of this type. So you definitely want to make sure that you recognize the two different triangles. So here we have a cube with an edge that's 5 inches. How can we find the length of the red line segment that is inside the cube? If we draw a right triangle inside of the cube, so there's one side, there's the other side.
That one that we drew.
Do we have enough side lengths to find the length of the red line segment? Well, right now we really only know that this side is 5 inches. So, we're missing the bottom leg. in order to use the Pythagorean theorem to solve this
Right.
problem. So let's draw another triangle. Here's one on the bottom. So we know that each of these sides of the triangle, or the legs, are 5 inches.
Okay, because
So
it's
we
a
can use
cube,
the
right?
Pythagorean theorem to find the bottom of our red triangle. So let's do that.
And they go fast,
So
so
we have our Pythagorean theorem, and now I plug in the legs. 5 squared plus 5 squared equals x squared. 25 plus 25 equals x squared. 50 equals x squared. Now you take the square root of each side.
So, this is where I want you to always stop when we do these. You're going to tell me x is equal to square root of 50. The reason is what happens when I take the square root of 50 and square it? I get 50. So why get a decimal that then, because in the next step, that's what this length is square root 50 right down here. In the next step, I'm going to take this leg, square root 50, and square it. Well, that's going to come out to be just 50. We don't want to have to mess with a calculator and put those decimals if we don't have to. So you're going to see as she finishes solving this problem, she does it with keeping it as a decimal. I just want you to know that we're going to stop at square root 50, the same when you do your homework.
And x is 7.1. So now we know the bottom of the
Or square
red
root
triangle
50.
that we created is 7.1.
We're halfway
Just
there.
from the information that we already know. We know the edge of the cube is 5 inches. And we just found out that the bottom of the triangle that we created is 7.1. So now we can use
Square
the
root 50,
Pythagorean
right.
theorem to find the length of the red line segment. X, we'll call. So leg squared plus
Have
x squared
another
is
right
hypotenuse squared.
triangle.
5 squared plus 7.1 squared equals x squared.
So again, this is where if we would have kept square root 50 and you square it, you would have just had 50. That's what I want you to get on your calculator. So you're going to add 50 plus 25 is 75. We're not going to have 75.4. So please on your calculator find the square root of 75. You're going to see they do it.
15.4 equals x squared. 75.4 equals x squared. Square root of 75.4 equals the square root of x squared. And x equals 8.68 for x.
Got the same thing? Okay. 8.7 about 6.8, which you should have, but why would we want to deal with decimals if we don't have to? And we really don't have to as we are doing this problem. So that's kind of as they are showing it. The thing that I like about the video is they're way better at their 3D drawings than I am. I am not great at drawing those, so it works well for me to kind of show it in the video where they kind of do that. Sometimes there's some videos where they'll kind of even do this as a, like they'll color this, like this is my one right triangle, right? So you can see it a little better. And they'll say, oh, this is the other right triangle down here, and you can see them a little better. So the key thing is, I want you to draw right next to this. This is going to be the triangle from A to F to E, where we had 5, 5, and we just said square root 50. Okay? When we go to this next triangle, when we do this one, this is now, find AD. This was A and this was D. Well, this is going across here, E. What did we just find over here that AE was? Square root 50, that goes here. This was the 5. This was the square root of 75 that they found in the problem. Okay? So there's always going to be 2 right triangles that you have to do when you're looking at these problems. Some of you, they're going to be no problem. We're going to do a practice one in class because there's 4 of them in your homework. We're going to do a practice. The other thing that you're going to be asked to do is find the volume of the cone and find the missing length. A couple of key things. Cones, spheres, and cylinders are 8th grade standards that you need to know how to find the volume on. You will see this formula coming up towards the end of March, and they're hoping you know or memorize these, so just a heads up, state testing end of March. This is a formula that you kind of need to have memorized. So this is the volume of a cone. What is the volume of, if it was a cylinder, What's different about that formula? It is just pi radius squared times height, right? So if I'm looking at a cylinder and a sphere, or a cylinder and a cone, excuse me, and they have the same height and radius, this one holds a third as much. So volume is always going to be unit cubed when we look at this. So our radius is always half the diameter. So in this problem, they say what's the diameter is 6, which we are going to write our radius would be 3 inches. So we have the radius that we need for our formula. This is the slant height. It is not the height. In order for the height, I want you to make sure you write in, this is our height going here. The height and the radius are always perpendicular, right angle. So what's nice about this is that we have a right triangle, right? And our right triangle has 3, 6, and this is going to be my height that I'm trying to find. So before I can find the volume, I need to make that right triangle. And I can't put my formula in with the 6. So Peter, don't go ahead and do this right now. So we are taking a look, and I want you to find the height. So if we are writing our Pythagorean theorem, what should I be writing down, John? What would I put on my paper to solve? You want to start with 3 or 8? The Pythagorean theorem says, right, a squared plus b squared equals c squared. What do you want to put first? This right triangle. I just need one number, A, B, or C, and tell me where to put it. The 3, where am I going to put it? Is A, B, or C? Okay. And we'll keep going. So 3 squared plus h squared. And if I'm looking at that bend, c squared should be in this case. My c should be 6. So 9 plus h squared is equal to 6 squared or 36. When I take 36, Marcus, and subtract 9, I'm ending up with 27. Again, I'm going to tell you, keep it exact. If you're that engineer and you're looking at the water flow and how the water is flowing through these pipes or doing different things, you want to keep it exact till the very last minute. So h is going to be equal to the square root of 27. We're not going to put the decimal in, okay? Especially when you're finding the radius and the radius comes out to be an irrational number, keep it irrational, keep it exact, okay? So this is the exact height. So now we put our volume formula and get those calculators out. If you don't have one, come up and grab one or take yours out because I want you to make sure you're putting it in right. So the formula is volume equals 1/3 pi radius squared height. When I'm finding this volume, I'm going to go 1/3 times pi. I'm going to use the pi button on my calculator when I do this in my homework. I'm going to take radius, which in this case was 3 squared. And then I'm going to take it times the height, which is square root of 27. So when I take a look at my calculator, and I am putting this in my calculator, I want to make sure that as I look at the calculator, I'm putting everything in. Keeping in mind that when you are putting in 1/3, that means 1 divided by 3. I'm taking it times, find the pi button on your calculator. So 1/3 is 0.3 repeating. Take it times the pi button on your calculator. If you're not punching in your calculator, please do so because I want to make sure you get the same answer that I do. I'm going to take 3, and I could hit the x squared because I'm squaring 3. And on my calculator, I have to put the 27 in, so I'm going to go times. I hit 27 and then I hit square root. Your calculator, you might put the square root in first, so just make sure using your calculator, because the square root of 27 is 5.2, about 5.19, this very long decimal. And now hit equal. So if I'm looking for the exact volume of this cone, I would have kept it with the square root of 27 and pi, but we're approximating it at this point. And I should have got, something doesn't look right on that one. Yes, it should be. So what did I miss? 1 divided by 3. Oh, I think I know. What did I miss?
times pi. I didn't square 3, right? 3 squared times, and then I should have had 27 square root equals. That looks way better. 48.97. Okay? So when I am looking at your answer, is it okay if you use 3.14 for pi? It's an approximation. It's getting less exact. Same thing if you use the square root of 27 to be the 5 point. Is it okay? Like, I'm probably not going to mark it wrong. But the key thing is that you are understanding how to get those exact solutions when we are taking a look at that. So we should have that our volume. So in your homework today, the first 4 questions are going to ask you 2 answers. The first one would be, what's my height? And they're usually okay with you saying, oh, that was 5.2? 5.19, I can't remember. Rounding it, and then our volume being, we ended up with, what was it, 48.9. Okay. Now I need a label with this. 48.9 what? Inches cubed. So making sure cubic unit as you look at this. Okay. We're not going to do both of these. This is just more application of the Pythagorean theorem. So it says so when you see a picture like this and we're trying to find out how far from either your house to your friend's house or your house to the marina, which one do you guys want to find? It doesn't matter to me. Okay, friend's house. So we're going to do the first one. How far from the friend's house to your boat house? So on my right triangle that I'm looking at, I have my house to the corner is 0.5 by the road, and then if I take this road, it's another 1.2 miles. So if I am setting that up, Ethan, what do I know in my Pythagorean theorem of a squared plus b squared equals c squared? 0.5 squared, okay, plus 1.2 squared. Put your calculator, put them in. I'm okay that you can tell me at this point c is equal to, so put that 69, the square root of 1.69, which should be 1.3 in this case, which makes sense, right? It's the hypotenuse. It had to be more than 1.2 was my longest side of my length. It had to be more than that. So this one makes sense if I'm thinking about that. We are not going to do the other one, but it would be using 0.4 squared plus 0.6 squared. And as you do that one, and then you add 0.4 and 0.6 squared, some of you might be doing it on your calculator. That does come out, if you were looking at that, to be 0.7 miles. Okay? Which makes sense again that this has to be the longest, 0.7 miles, right? This is 1.3. That makes sense for our picture. So always think about the longest side has to, when you are solving those. So sometimes people will get mixed up and put the wrong numbers in the A, B, and C. So this next part, one of our other standards is being able to look at drawing it in a plane. So you'll see something like this on state assessment too. So they give you 2 points, and what you're really looking at is the shortest distance between any 2 points is a nice straight line. So draw a straight line connecting those two. So we draw our straight line, then the next thing we want to do is we want to make a right triangle. Does it matter if you make your right triangle down below like mine is here in pink, or if you make yours up above like mine is here in green? Doesn't matter, right? Both right triangles. I'm looking at the legs of my right triangle. This is what I'm trying to find. This is what I'm trying to find is C. So this leg is 3. It's the same over on this side, right? This leg here, I'm writing down is 6. So please make sure you put the 3 and 6. Do I need you to write the a squared plus b squared? I don't know if you need to. You could, but could you just go show me at least what you did? Okay? Using those calculators, plug it in square root of 45. I want to keep the exact. This is my exact solution if I want the exact answer. And this one says, ooh, we want the exact answer. So we got to simplify it. I don't want that decimal. So what's the perfect square that goes into 45 like we did earlier this unit? Perfect square that goes into 45 should be 9. Oh, simplifying. 9 times 5. The exact answer in simplest form would be the square root of 9 is 3 square root 5. If I would put these two in my calculator, but it does say keep it exact, if I would put those two in my calculator, they should come out the same, okay? This is the better simplified answer as we are looking at, okay? This is where some of you kind of got mixed up on that last quiz. Keep in mind, not a big deal. We just got to move forward and get you understanding it. So please draw 2 right triangles, and I need you to tell me the side lengths of those right triangles. I don't care if you go above or below when you draw your right triangle, but check with your shoulder partners and the people sitting by you. I'm going to do one above, I'm going to do one below, and see if you agree just with your side lengths. That's what I want just you to do first. Try and find C to D. I'm going to find C to D. What were my 2 lengths? It was 2 and 7, right? So if I'm finding CD, I had to take 2 squared plus 7 squared equaled C squared, right? Now I'm looking at AB. What were my 2 sides of my right triangle for AB? Jada, would you have? 6 and 4. So again, when I set that one up, 6 squared plus 4 squared equals C squared. 49 plus 4, right? C is equal to the square root of 53. I'm going to keep it exact first. It asks me which one is longer. My AB came out with 36 plus 16. Can you put this whole thing in your calculator to just give me the one number? C is going to equal the square root of 36 plus 16, which gives us 52. So the first question is, they're not that much difference in length, correct? Which one is longer? 53 is bigger than 52, right? So we're going to say CD is the longer side. Approximate it out to the hundredths place, okay? So tell me approximately to the hundredths place, right? Hundredths. So if I'm looking at those, I know the square root of 49 is 7, so it's a little over 7. So 7.53 was what? 2.8. Not much difference, right? Square root of 52, we ended up with 7.21. It says how much longer is it? If it's how much longer, I want to subtract those two. How much longer from 0.21 to 0.28? 0.07 hundredths, right? If I subtract those two, 7 hundredths difference. Or what do I add to it? 21 hundredths to get 28, I add 0.07, okay? The last one is dealing with a monument. And again, a lot of times when there's all these story problems, I have people like, oh, I don't know how to do this. So, and how many of you have been to the Washington Monument? Anyone in here? For me, it's been many years. I know they've redone it, fixed it up. But, so let's make our monument all the way to the ground. And just so you know, we're assuming that this is a right angle with the ground. Okay, so here's the ground, right? Here's all my trees. It must have been like April or May. Actually, they said this year I heard that the cherry blossoms are happening a month earlier than they usually do. So usually it's April and May when they have all those beautiful trees. But regardless, so we're going to look at this. It says you're standing 500 feet from the monument. And you are using this, this rangefinder to measure the distance from the top that is 747 feet. Where should I be putting my 500 in this picture? On the bottom. That's how far away I'm standing. So this is like me standing over here, right? I'm this person standing right here, right? I am 500 feet away. What am I trying to find? How far from the finder here, or how? Which one of these am I trying to find?
How far it's from like the top of the thing to where you are.
Find the height of the Washington Monument. Isn't this what we know? Isn't this 747 feet? So if I'm trying to find the height, that's the H, that's this. That's my height, right? It's perpendicular to the base. So when you read the questions, you gotta think about what you're trying to find. So this one, if I'm setting it up, what should it be looking like as I set it up? Cole, wanna help me out?
A squared plus B squared equals C squared.
Okay. Do you wanna put just one of my numbers in?
500 squared.
Okay. Ellie, you wanna help me with another number?
Plus H squared.
Okay. Equals, and then Sierra, I'd be looking at? My hypotenuse on this one?
47.
747, and we want to square it. Use those calculators. Could I put in my calculator 747 squared? Do that first. Subtract 500 squared, right? To find h squared, I'm really taking 747 squared minusing 500 squared. But you have to make sure you hit the square button. My h, it's a pretty big number, right? They ask you to round it to the nearest foot. So I don't want to know a big decimal, and I don't want it exact. So when I take a look at this answer, I should have, you guys get it yet?
Yes.
555 feet. Woo! Okay. So if you notice in your notes, this is pretty much the end of the road for notes on this unit. You got what's on the test. We're going to talk about that Monday. Number 4's mistake is that they'll find the radius for their answer first, and they forget that the question says find the diameter and then find the volume. So you're really finding 3 answers in number 4. These are the 2 that are in the back, the volume and the diameter when you check. This one, do I need this length to find the volume? No. But do they ask you to find what x is? Yes. Would you just simply find the volume first and then go back and use Pythagorean theorem? Yes. So I want to look at questions 5 through 8, and I want you to pick one. It doesn't matter to me which one. And I want to show you what your work might look like for me, because the video was the only place we did it. 6. Really? 6 because it's just,
It's just one. It's small.
it's small. It's going to be the same. Let's go with where you can see me draw it out a little better. So let's go either 7 or 8. Okay. So the reason I'm picking one of those ones is that there's more room to show your work down here. Okay. So here's the deal. Please draw this right triangle connecting A to E. And draw that picture. The first triangle we're going to have A, F, E, and make a right angle. And when you make that right angle, let's put in what we know the lengths are. The length from A to F was 15. The length from F to E was 8. We're going to draw a second right triangle. That second right triangle is going to have from A to E, this time all the way up to D. What do I know the length is from E to D? E to D. 10. Put that in here. I want you to notice that this AE and this AE, they're going to be the same, right? I need to find this length before I can find this, before I can find this C. Okay? So let's start this one out first. My Pythagorean theorem is going to tell me to take 8 squared plus 15 squared equals C squared. Use those calculators. 8 squared plus 15 squared, right? If we are taking a look at that. So 8 squared plus 15 squared. Put 5 squared. Oh, I did. Thank you. Okay. So I get 15
squared plus 8. And hopefully, like I did there, you notice that that doesn't even make sense. That it could be that, so 289. So C is equal to the square root of 289. Did I do it right? Okay. Is that a perfect square? So I put it in the square root and I go, oh, that's beautiful. I get to use 17. I don't have to keep it as a square root. Okay? That's what this length is, which these are the same length. So now I can put the 17 in here. Okay? Someone was asking on some of our tests, what's a level 4? A level 4 is that there is a way to do this without doing the Pythagorean theorem twice. That's one of the things that we've looked at as math teachers is, you know, you could figure that out and you knew how to do it, showing you were doing it without doing the Pythagorean theorem twice. That would be a level 4. Like 3 is proficient, right? That's a level 4 question. In this one, we're going to go 17 squared plus 10 squared equals C squared. Again, use your calculator. 17 squared plus 10 squared or plus 100 gives us 389. So C is equal to the square root of 389. What does C equal? I'm going to take the square root of 389 and put it on my calculator. 19.7 is my final answer. So what is the length from A to D? AD is equal to 19.7 in this case inches. Okay? On the East Coast and all of our, how we talk very Midwestern. For sure. Oh yeah, you betcha, that kind of stuff. They always make fun of it. Make fun. I can do it.
Bad.